contrails, which are short for condensation trails, are formed when water vapor is emitted from the aircraft and condenses on soot particles to form ice crystals. And this in particular happens in so-called ice supersaturated areas of the atmosphere. And the way this contributes to climate change is quite complex, because actually in the morning and in the evening you have a cooling effect. But then, and that is when the sun is low on the horizon. But then during the day, when the sun is high up in the sky, and also during the night, there's a warming effect. And this is because contrails actually reflect part of the solar radiation during the day, but during the night they instead trap the heat and the infrared radiation and stops it from disappearing from the Earth's atmosphere. And the conclusion in terms of climate change that you can draw from that is that if you reduce the number of soot particles and the amount of sulfur dioxide that you emit, you can also reduce the formation of contrails. So if a pilot reroutes a flight, it can actually lead to the reduction of contrails, but there are a number of factors that are important to take into account when you consider that. And first of all, there's the potential of a trade-off between, on the one hand, contrail formation, and on the other hand, carbon dioxide emissions. Because if you reroute, you probably fly a longer distance, which means you consume more fuel, which leads to higher carbon dioxide emissions. And that trade-off has not yet been scientifically established. Secondly, what is also important is that we need to be much better in predicting the location of these ice supersaturated areas. Currently, we're not very good at finding out exactly where they are, and we need to know where they are at least 24 hours in advance. Yes, they are definitely more sustainable, and that is because both the European Union and globally, in the International Civil Aviation Organization, we have established strict sustainability criteria for these fuels. And that ensures not only that they have lower life cycle carbon dioxide emissions, but also that other negative consequences are avoided, such as the biodiversity loss. And the way it works is that they contain fewer aromatics and fewer and less sulfur, which means that when they're burned, they do not only create fewer carbon dioxide emissions, but also less contrails. There is at least one company that is actually based in the United Kingdom that offers this type of technology to airlines to help them reduce their contrails in their daily operations. Whether or not this will become a general trend in the industry, I think it's too early to say, because it will, to a very large extent, I think, depend on this issue about the trade-offs between carbon dioxide emissions and contrail formation. The scientific consensus on that is not there yet. Yes, I think it's fair to say that so far, the focus of the aviation industry has been on carbon dioxide emissions. But they are also very much aware of the fact that contrails also contribute to climate change. From the 1st of January 2025, we are also preparing new legislation mandating the blending of sustainable aviation fuels into kerosene, conventional fuels.